In this video, we are going to understand how to derive the formation of bus admittance matrix by using singular transformation method. That means we need to get Ybus is equal to, that is bus admittance matrix, which is equal to the A transpose matrix into Y into A matrix. This is what we need to get. This is the derivation for that. So let us consider, the first step is that let us consider a oriented graph. An oriented graph. Any oriented graph you can consider. So let me take three nodes with one as reference. In singular transformation method, you should know that one you have to take it as what? The reference. So ground it. So here I'll take three nodes. Let me name it as B, A, B, C, A, B and C. The ground one or the reference one as 0. Okay, just join it. So all the nodes are basically connected to the ground. Next one, I'll just give the numbers or the numbers for the lines. Here any direction you can give. So let me just number it: 1, 2, 3, 4 and 5. Total 5 lines. Okay, this is just an consideration. Okay, you can consider any graph. You have to just derive it, that's it. So basically I'm going to write A first, A matrix. So how to write A? So that's why I have considered oriented graph here. So based on the oriented graph, we have to write the A matrix. What is A matrix? It is nothing but number of nodes and number of lines combination, right? So number of lines I have to write it over here. How many lines? 5 lines. So 1, 2, 3, 4, 5. And number of nodes I have to write it here: A, B and C. So we should not consider the ground one, reference one. Okay. So totally 5 cross 3. That means 5 is nothing but the number of lines and 3 is nothing but number of nodes. Okay, this is the order of bus incidence matrix. This is bus incidence matrix. Okay, now I have to write it over here in this matrix. I have to fill it. How we have to fill it? Based on the directions. Okay, so on first node, that is A node, what all lines we have? 2 lines we have, that is 1 and 4. So 1 and 4 we have to put it as 1, 1. Remember, so first 1 and 4 line are there, so that's why I'm putting as 1 and 1. Rest all that thing 0. Now for here we have to see the direction also. So based on a direction you have to give plus or minus sign towards the node. If the direction is there, then it is what? Negative. If it is towards the node, then it is negative. So here we can see 4 is going away from this A node, correct? And 1 is also going away from this A node. So we have to put it as positive. So it is plus 1 only. Okay. Next, B node we will take. So B node, if you see, we have 3 lines. So let me just use another pen. So B node we have 3 lines: 1, 2, 3. Okay. What all lines we have? 4, 5 and 2. So for 4, 5 and 2 I have to put 1. 4, 5 and 2. Rest all 0. Now we have to see the direction. So with respect to B node, 4 is coming towards the B node, correct? So for that we have to put minus. 5 is also coming towards B node, again minus. The second line is going away from the B node, that will be plus. Next, C. For C we have to take C node, we have 2 lines, 5 and 3. So let me just put for 5 and 3 1. Rest all will be zeros. And see here, with respect to C node, 3 is going away from C and 5 is also going away from C. So basically that will be positive. Away means positive, towards means negative. So this is, we have done with the bus incidence matrix. A matrix we have done. That means we have calculated this part. Now we'll go for A transpose. We have to take A transpose. A transpose is nothing but, transpose of the matrix is nothing but line, the rows becomes the columns and columns becomes the row. So it is 5 cross 3. Now it will become 3 cross 5. 1, 2, 3, 4, 5. Here A, B, the same thing only. Okay. So 1, 0, 0, 0, 1, 0, 0, 0, 1, 1 minus 1, 0, and last one 0 minus 1, 1. Okay. So write it over here. This is 3 cross 5. Transpose as that matrix. Now here in this we have to observe that the voltages, we have to see the node voltages. Okay, so if you observe the node voltages, that means with respect to the node voltages A, B, C we have. So for that particular thing we have to see the node voltages. So let me just take this column. So it is related to 1, first line. Here we can write it as VA, V1 is equal to VA, correct? V1 is equal to V, this one. Okay, second column if you see V2, V2 is nothing but the V1, V2, V3 are all what? Line voltages, correct? VA and all will be node voltages. So line voltages and node voltage. So line voltages V1, V2. V2 will be second column if you see we have the B, that means equal to VB, correct? Third column if you see V3, which is equal to, here we have VC, only VC we have, correct? And fourth voltage, line voltage if you see fourth column, here we have A as well as B, correct? So VA, here minus sign is there, so minus VB. Next, fifth line if you see, here for B and C we have B is minus, so minus VB minus, sorry, plus VC is positive 1. So this is nothing but the relation we are trying to develop. Okay, so what is the relation between the line voltages and the node voltages? Now, so from this we can get to know that it is basically, we can, from this we can understand that the element voltages or the line voltages, element voltages matrix will be equal to the A matrix into the node voltages or the bus voltages. So multiplication of this will give me what? Element voltages V1, V2, V3. Correct? From that only we derive. So element voltages or the element voltages basically means V1, V2 till V5. Okay. Node voltages VA, VB and VC. So this element voltages equal to the bus incidence matrix multiplied with the VA, VB and VC. So basically it is nothing but, if you see here, V1, V2, V3, V4, V5 will be equal to the A matrix, whatever we had written over here, correct? Starting bus incidence matrix, that matrix, that is 1 0 0 0 1 0 0 0 1 1 minus 1 0 0 minus 1 1 into the node voltages or the bus voltages VA, VB, VC. Okay, so this is nothing but what we wrote here. Okay, this part if you see, this is what I wrote here, the relation. From this only we are getting. So if you multiply and see this matrix, you will get the same thing, relations. Now let us try to understand using the matrix form. So this is basically, so I'll just tell you what all steps we are involving. First step is that you have to consider the oriented graph, then you have to write the bus incident matrix, A matrix. Second step is that you have to write the A transpose matrix. Third step is that you have to form the relation between the element voltages or the element, or we can call it as line voltages, and the node voltages relation we are trying to get using the bus incidence matrix. That's it. Okay. Now let us go for the next step. That is nothing but this. I can represent it as V matrix equal to A matrix into the bus voltages or node voltages. So I can write it as V bus. Bus voltages or the node voltage is the same thing. Okay. Just mark it as first equation. This is one important equation. Now let us consider the next step. Okay. So almost we can say first step, then we wrote the second step over here. Third step is to write the A transpose and trying to get the relation fourth step. Okay, the same thing. Let us go for the fifth step. So basically fifth step, what you have to consider, we have to consider the performance equation of primitive admittance matrix. What is that? It is I plus this, you have to remember, okay, this step, plus j is equal to y into v. Okay, so name it as second equation. So best just remember this is the derivation, so you have to remember the performance equation will come in the fifth step. Okay, here what I am going to do is that here you can see V, correct? V matrix is there. This is nothing but the line voltages or element voltage. The same thing is over here also, line voltages or the this thing. So I can replace this one with V. So the equation becomes I plus J is equal to Y into A into V bus, correct? Okay, this will become third equation. Now the important step here is that we have to pre-multiplying. Pre is nothing but before a number, suppose 3x is the number, pre-multiplying means before this thing I am multiplying with 2, something like that. Okay, before, only before the element you have to multiply, that is pre-multiplying both sides So basically in sixth step we are pre-multiplying both sides of equation 3 by what? A transpose matrix. So what will happen? A transpose into I plus A transpose into J equal to A transpose into Y into A matrix into V bus matrix. Correct? Okay. So this thing I will limit as fourth equation. So basically this equation, third equation, I am just multiplying with A transpose, pre-multiplying before I am multiplying. Both the sides we are multiplying. Now next step is very important. You need to understand here this A transpose into I is nothing but 0. Why it is 0? Because this is a vector. This vector A transpose into this I is nothing but a vector whose elements are algebraic sum of this vector is nothing but the algebraic sum. Okay, so this matrix A transpose into I is nothing but the algebraic sum of current flowing through elements incident at the bus. This is nothing but 0. So the algebraic sum of current flowing through that bus. For example, if I say we had considered 3 bus B, bus A, bus C, correct? 3 buses, all thing grounded. Now here if I say the current flowing through this one, for example, we had taken here 4, 1, 2, 5, 3 and this is 0. Okay, now here if you see, I can say that I1 plus I4 is equal to 0. That means at a particular node, the line voltages sum will be equal to 0. That's what this statement says. Okay, so I4, for example, I4 plus I5 will be equal to I2, correct? Like that. I5 plus I3 will be equal to what? 0. This is for C node, this is for B node, and this is for A node, like that. So for particular nodes, the algebraic sum of the current flowing through that elements, that line, will be what? 0. So this vector will be what? 0. So this I can replace it with 0. Now next, this coming to this part, A transpose into I. A transpose into I, sorry, I is finished. We are going for J. A transpose into J. This is also a algebraic sum. So here also you need to understand, A transpose into J is nothing but a algebraic sum of all current, but here it is nothing but sources, current sources incident at each bus. There is a difference, correct? This is current sources at each bus. Okay, so this thing I can represent it as I bus. This you have to remember. A transpose into J is nothing but I bus, but A transpose into I is 0. This thing you remember in this derivation. Okay, so I am just putting 0 plus A transpose into J is nothing but I bus. I write it as I bus equal to, the A transpose will remain as it is, Y and A and B bus, correct? Here I can say that this whole thing, whatever it is written over here, 3 elements, 3 matrices. So basically this I can write it as I bus is equal to Y bus into V bus. Okay, I is nothing but what? V by R, correct? I is R, we can write it as impedance. Impedance will go up, it will become what? Admittance. That's basically is this. I bus is equal to, I is equal to Y bus into V bus, where I bus is nothing but, not I bus, sorry, Y bus is nothing but equal to A transpose into Y into A. So this is what we had to prove, correct? So here, from here we have proved that Y bus is equal to A transpose into Y into A. And one more thing, always remember, A transpose should come in first place only. Don't put over here, okay, somewhere else. This is the order through in which you will be multiplying. Okay, this is the derivation of this thing. So let me just briefly tell you what I have done. So I have basically considered an oriented graph, and the second step is that I have made one incidence matrix based on the oriented graph. You can take any example of oriented graph. Based on that, you have to make the incidence matrix. And third step is that I am forming A transpose of that matrix, and I am trying to get trying to get the element voltages or the line voltages relation with the node or bus voltages thing. Okay, using incidence matrix, bus incidence matrix, which is nothing but A matrix. So this is what the relation is. The element voltages is equal to A into the bus voltages or node voltages. Okay, this name it as first equation. The fifth step is that for primitive admittance matrix, that is the Y, small y matrix, performance equation is I plus j is equal to Y into V. Okay, I plus j. So for in place of V, I am putting this equation, first equation, that will become A into V bus. Next step is that sixth step, I am pre-multiplying with both sides for the third equation by A transpose. So it will become A transpose into Y plus A transpose into J, A transpose Y, A and V bus. Now here A transpose and I is nothing but 0. A transpose J is Y I bus. Okay. That step you need to remember. So Ibus is equal to this thing we got. So here the Ybus is nothing but A transpose Y into A. So just rewrite this part as Ybus. Okay, so Ibus is equal to Ybus into Vbus, where Ybus is nothing but A transpose Y into A. This is what we had to prove. This is basically the derivation.